Today we're going to be talking about a X-linked recessive genetics. If look at this picture and you cannot see a W in that dot picture, then you might be someone who has red-green color blindness. For those of us who do not have red-green color blindness, these are the colors that we see with normal vision. And someone with red-green color blindness, their vision in the red and green wavelengths is altered, and it's brown and yellow in color. This type of genetic disorder is inherited by a X-linked recessive. So what does that mean? Well, it's a recessive trait. So in order to have this, you have to have a copy of a recessive allele, but it's linked to the sex chromosomes. So when we're looking at a genetic inheritance pattern that looks like this, instead of just looking at a recessive trait being little a, we have to take into account whether or not it's on the X chromosome. So if you remember back, we talked about females being XX for their sex chromosomes and males are XY. So one of the reasons why red-green color blindness is so prevalent in males, or more common in males, is that males only have one X chromosome. So in order for a male to be red-green colorblind, they only need one copy of that recessive allele, and they will be red-green colorblind. Females, because they have two X chromosomes, they are going to need two copies of that recessive allele. So a female that is colorblind would look like this for their genotype. A male that's colorblind would look like this for their genotype. A female with normal vision could be X big A, or she could be X big A, X little a. In this case, she's what we call a carrier. So if you are a male that is red-green colorblind and your mother is not, more than likely she is a carrier. And if you trace back in your family history, you might have a grandfather or a great-great-grandfather or even a grandmother who is colorblind. Now, males with normal vision are going to be X big A, Y. So the way that we do these Punnett squares is very similar to how we've done complete dominance Punnett squares. So let's set up an example. A normal female marries a colorblind male, and we want to know what is going to happen with this genetic cross. So because this says normal, we're going to assume that that female is not a carrier. So she's going to be X big A, and we're going to cross that with a colorblind male. So he's going to be X little a, Y. Now everything else is pretty much the same. So we're going to set up the Punnett squares the same. Mom's going to go down the sides, so it's going to be X big A, and we have to keep those together because remember, this is saying that it's on the X chromosome. And then the male father is going to be across the top, so X little a and Y. Nothing's on the Y because that gene is not found on the Y chromosome. So when we fill this out, we fill crossed and down just like we have been. Now we have to look at our female boxes and male boxes separately. So in this particular cross, there's no chance of having a colorblind child. 100% of the daughters or the females are going to be X big A, X little a carriers. and 100% of the males will be X big A Y. So no colorblind people in this particular pedigree, or Punnett square.